Everybody. So welcome back. We're on our fourth video for Unit 3's notebook. In the previous video, we talked about domain and range. And remember, domain is the Dixie domain independent input values, X values, independent variable. And then Royd was the range, output values, Y values, and dependent variable. So now we're going to be talking about domain and range restrictions. So thinking about specifically word problems, what happens when we have to restrict what our X values are, so therefore it's going to restrict what our Y values are. So we're going to be looking at a word problem, and then you're going to do the other word problem on your own, okay? So let's look here. Crap. There we go. Let's see if I can zoom in. Nope. Okay. See if I can zoom in a little bit more for you guys. There we go. Okay. Awesome. So we're talking about a local theater sells admission tickets for $9 on Thursday nights. At capacity, that means at the maximum number they can hold, the theater holds 100 customers. So we are talking about selling tickets at a theater and then how many customers they can have in the theater itself. So we're looking at right here. They want us to know what depends on what. So what's that dependent the depend statement. So think about it, does the amount of money for the tickets depend on the number of customers they can hold, or do the number of customers they hold depend on the amount of tickets? The amount collected, okay, so that is how much money they earned, depends on the number of tickets they sell. So money depends on tickets, so how many customers really, because a ticket represents a customer. So money depends on tickets or customers. So the dependent variable is the amount collected, the money. If you want to use the word money, you can. So money is the dependent variable because that's going to change depending on how many people buy a ticket. So dependent variable is the amount of tickets or the people. And now, is this going to be a discrete or a continuous? So let's review those vocabulary words. Remember, discrete means it's a problem that is, you can't have half of something, and it's not going to be connected if I have a graph. So it's like 1, 2, 3, 4, so on. There's no, in between, no like 1.5 or anything like that. And then continuous goes on forever, and it has values in between those whole numbers. So like 1, 1.5, 1.3, then all the way up to like 10 and so on. It goes on forever. So let's think about this. Our two variables are money and number of tickets. Now, money can be in change form. I can have $1.50. But in this case, I'm only talking about $9. There's no change. So we know we're not going to have any change in this problem. And then the other one is talking about number of tickets or people. Can you have half a ticket or half a person? No. So I'm not going to have continuous. I won't be able to have the in-between numbers. So it has to be a discrete. So that means we're only going to have whole number answers. So now we got to think about our domain and range. So domain, again, is the X value or the independent variable, and that is an amount of tickets or people. What's the smallest amount of tickets or people the theater can have? 0. I can't have a negative person, so I know I have to have my smallest number be at 0. So it's going to be 0 and then 1, because I can't have half a person. 0, 1, 2, and so on. Now, is there a limit on how many people that the theater can have? Yeah, it says at the capacity, the theater holds 100 customers. So my domain will go from 0 to 100, counted by whole numbers. So 0, 1, 2, all the way up to 100. Now we need to talk about our range. Remember, range is the same thing as the dependent variable or the Y value. And in this case, that's amount collected or the money. So how much is the smallest amount of money they can have? Can I have negative money? No. So what's the smallest amount of money? Well, if I have no customers, I haven't made any money. So my smallest amount of money is $0 as well. Now I am thinking about, all right, how much, if I have one person, how much money is that? Well, let's look back at the problem. It says a local theater sells admission tickets for $9. So every person that comes into the building, I get $9 from them. So $0 for 0 people. One person has to pay $9. So it's 0, then 9. All right, how about 2 people? That is 9 times 2 because it's $9 per person. So that's $18. So I'm counting by nines. All right, so if my smallest amount is 0, that's $0, 0 people. Remember, the theater only holds 100 people. So what's the maximum amount of money I can earn? Well, again, every person pays $9. So what's $100 times $9? 100 people times $9. That's $900. So my range is 0, 9, 18, skip counting by 9 all the way to 900. So that's what it means by domain and range restrictions. It's going to have a certain type of pattern, and it's going to have usually an ending point and a starting point because of the word problem restricts what types of numbers it can have. So this is one example of a word problem that has that type of scenario. Your job is to do this one right here. Carla charges $15 per hour to clean houses. She also charges $10 for the cleaning supplies. So $15 per hour to clean plus $10 fee for the supply she needs. Because Carla has so many clients, she refuses to spend more than 4 hours cleaning a single house. Okay, so you're going to think about what depends on what. So what are your two things going on here? What is the dependent and independent variable? Is this a discrete or continuous? That means, can you have half of something? Can you have half money? Can you have a half hour? Something like that. And then what's the domain and range? Think about what's the smallest amount and then what's the largest amount. So giving you guys a hint, we're looking at money and hours here. So think about that. Okay. Think about how much money and think about how many hours she can work. So you're going to fill that in on your own. All right. And I will see you guys in the next video. Bye.